Who's going to be up there with us? Clay will be decent.
Clay will be decent. Will be decent. That's about it.
Soon Valley won't be any good.
Right now.
Again?
They're 2-0.
Who'd they be?
Huntington.
They must be awful.
Some Valley lost.
Who?
Music, did you do T minus U to come up with 3 and then square it to get 9? Did you already find your mistake?
Yeah, just now. Yeah.
Oh, okay.
I don't know. Yeah.
Yeah, they're big and so like always, and Brandon said that they're so.
I'm expecting like 6 and 4.
Who?
Today's winning number is 1.
Boom.
Example 1. You have a compound fraction. And what you need to do to simplify this, I need a yellow marker real quick. There we go. To simplify this, you have to take care of the top first and the bottom second. On the top, you have to add 3 and 1 over x over 2. So you need a common denominator. The common denominator between 3 over 1 and 1 over x squared would be what? Not 1. If you multiply them together, you get what?
Multiply that together.
The denominators.
At the bottom.
Yep.
You get x squared.
X squared, right. So you need 2 fractions, each with x squared, and the one on the right already has an x squared as a denominator, so it stays 1 over x squared. But on the other one, what you do to the bottom, you have to do to the top. So you have to multiply the top by x squared, so you would have 3x squared. Then on the bottom, you go do the same thing. Find a common denominator.
Yeah.
It would be x, that's right. So 2 fractions, both with a denominator of x. 3 over x stays because it already has an x as a denominator. But what you do to the bottom here, you must do to the top, so that gives you 4x.
Then you just 3x squared divided by x squared would equal 3.
Well, that'd take us right back to where we started. What you'd have to do is add the numerators. So 3x squared plus 1, and just put it over x squared. And then the bottom is 4x minus 3 over x. Now you can do a revision here. This divided by this is the same thing as that top, 3x squared plus 1 over x squared, multiplied by the reciprocal of that bottom. So x over 4x minus 3. You flip and multiply. And then from there you multiply straight across. So x times this quantity is 3x to the third plus x, and on the bottom you would have 4x to the third minus 3x squared. Once you get to that point, you have to figure out, is there something I can take out of the top and something I could take out of the bottom that would allow me to cancel out? For example, what can I take out of the top? The top 2 terms both have at least what in common? Can I take an x cubed out of this one? No, so it would just be what? X, right. So what would I multiply x by to get 3x to the third?
3x squared.
3x squared is right. And what would I multiply x by just to get itself? Not x, that'd give me x squared. 1, right. Now on the bottom, what can I take out?
X.
What's the highest factor? You can, he's right. You can take out an x squared, but if you take out an x squared, is the x squared going to factor out or divide out evenly with this x?
No.
If I have an x squared on the bottom and an x on top, when I cancel them out, I'm left with an extra x on the bottom that I have to go back through and multiply to simplify it. So only take an x out on the bottom. If If I do that, x times what is 4x to the third?
X, 4x squared.
Right? And x times what would give me 3x squared?
3x.
3x. So now I have something that I can cancel top and bottom. There and there. So I just go back and write my final answer. 3x squared plus 1 over 4x squared minus 3x. Alright, so we have 5 over x plus 1 over x squared. And then all of that is over 3x over 5 plus 2 over x. Up here on the top, green doesn't look very good on blue, so I'm going to go to this one. There we go. On the top here, I have an x and an x squared. What would be the common denominator between x and x squared?
X.
It wouldn't be x because x squared is too big.
1.
Not 1. Think of it like a 3 and a 4. You have to.
Over X.
What would be the common denominator between a 3 and a 4? 12, because you multiply 3 by 4 and then 4 by 3.
Well, then it would be x.
No.
X cubed.
What you have to think, between x and x squared, there's something that I can multiply each of those by in order to make something that's as low as possible. Now, think of that x squared, and I'll show this work off to the side. Think of that x squared as a 6 and the x as a 2. If I needed a common denominator between 2 and 6, what would it be?
12.
Not 12.
6.
6 is right, because the 6 goes into itself already, but I have to multiply the 2 by something to get 6, which would in this case be 3. Think of that just like this here, x and x squared. Is there something I can multiply x by to get x squared? What is it?
X squared.
No, I wouldn't multiply by x squared.
You multiply by X.
You would multiply by x, that's right.
I said x.
That was our first answer.
No, you said that I was asking for the common denominator, and x would not be the common denominator, it's x squared. But you multiply by x to get the common denominator. Oh my gosh. Well, multiply this by x and this by x to get 5x over x squared, and then the 1 over x squared just stays the same. On the bottom, between 5 and x, what would be my common denominator?
X.
Not x,
5.
not 5.
1.
Whenever you get to a position where 5x, that's it, he's got it. It is 5x. What do I multiply the top and the bottom of this fraction by to get 5x on the bottom?
X.
X, so I have to do it on the top and the bottom. What do I do to this fraction to get something over 5x?
5.
Multiply by 5. So that's 3x squared over 5x plus 10 over 5x.
Then you flip the second one multiply.
Not yet. What you have to do, as soon as I erase this stuff over here on the right, there we go, make the marker bigger. Now we're ready. Let's see, I need this marker in yellow. Okay. You have to simplify the tops. 5x plus 1 over x squared, and then 3x squared plus 10 over 5x. Now you can flip and multiply. So 5x plus 1 over x squared multiplied by the reciprocal of the bottom. So now it's 5x over 3x squared plus 10. And once you have that, you can multiply left to right. What would I get on the top when I multiply 5x by 5x plus 1?
25x squared plus 5x.
That's right. And what would I get if I multiplied x squared through by 3x squared plus 10?
3x to the 4th plus 10x squared.
That's right. Now look at the top and the bottom. What is my lowest power of x?
5x.
Lowest power of x.
X.
Just x, right. So that means that's all I can take out, because if I take out anything higher, I won't be able to accommodate that x. So take out an x on the top and be left with 25x plus 5. And on the bottom, take out an x and be left with 3x to the third plus 10x. So your x's cancel, and you're left with your answer of not 30, but 25x plus 5 over 3x squared, not squared, cubed, plus 10x.
You could reduce it even further if you wanted to.
How could you reduce it further?
25x in 10. You could take the 5 and 2.
You can only reduce the 25 and the 10 if the 5 and the 3x cubed also have that same factor that you're taking out of it.
Okay.
On the practice problem here, we should have 6x over x squared plus 3 over x squared. And then on the bottom, your common denominator is going to be 2x, so you'll have x squared over 2x minus 2 over 2x. And if you simplify that, 6x plus 3 over x squared and x squared minus 2 over 2x, you can now flip and multiply by the reciprocal, so 2x over x squared minus 2, and then that's going to give you 12x squared plus 6x over x to the fourth minus 2x squared, sloppily drawn 2x squared. The lowest power of x is just going to be x, so take out an x on the top, leaves you with 12x plus 6, and on the bottom you can take out an x, so x to the third minus 2x. Cancel these and you're left with 12x plus 6 over x to the third minus 2x. Alright, so on the top you have a 2x. You have a 2x, that's supposed to be a hot or a laser, there we go. 2x and 2. I want to make these both the same thing with doing as little as possible. Is there anything that I can make one into the other?
You make them both 2x.
Yeah, I can make them both 2x, and what would I have to multiply the top and the bottom here by? To get a 2x on the bottom, what would I multiply by?
X.
X, so if I do it to the bottom, I have to do it to the top.
So then you have x squared on the top.
Yeah, so the 4 over 2x doesn't have to change, but this is x squared over 2x. We changed this to be a 2x by multiplying by x, but what we do to the bottom we have to do to the top. So that would give us x squared here and 2x there. Does that make sense? Okay. On the bottom, I need to get my blue marker back. There we go. On the bottom, we have an x and a 2x. What can I make these both into?
Yeah.
Yeah, there's a 2x there already, and all I have to do is multiply this by x. So what I do to the bottom, I do to the top. So times x would give me 3x over x squared minus 1 over 2x, because that 2x on the bottom did not have to change. Are you with me to this point? Okay. So now once you have the same denominator here and then the same denominator there, you add the tops or subtract, whichever it says. So you combine these together in one numerator. 4 plus x squared, then on the bottom is 2x. The bottom of the larger fraction here, you combine these together.
Wouldn't the bottom be 2x squared?
Oh my goodness, I can't believe I went through most of this problem and not realizing that. That was, you don't multiply this one by x. Somebody said x and I wrote it down. You multiply it by what?
2.
2, yeah, so that should be a 2. That means this whole thing here is a 6. And then on the bottom, this is a 2x. And we can just scratch this out. There we go. Now that's much better. So you would have 6 minus 1 over 2x. But can I simplify 6 minus 1? Yeah, what would I put?
5.
5. So 4 plus x squared over 2x. And then we'll flip and multiply and change that to a 5. So it's going to be on the bottom, and the 2x is on the top. Should I multiply straight across top and bottom, or is there something I can do to cancel out somewhere before I do that?
I would just multiply first and then take it out of the division.
It might be easier to do this. If you cancel those out now, then it's just 4 plus x squared over 5.